So, first of all, y'all all know how to do most of this because y'all know how to, I'm trying to find my mouse. There it is. Most of y'all have done y'all's test grades for the class from what, 6th and 7th grade. Y'all learned how to do your grade for the semester by what? Add them all up. So you've done this before. Now we're going to do all of it. And there's mean, median, mode, range, mid-range, variance, and standard deviation. So with that being said, I want you to write down very quickly what we're fixing to go over because most of y'all have had it. But those of you who haven't had it, make sure you watch this video, okay? Because you may not write quick enough, okay? I don't know. But I'm going to go through this, blah, 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 blah. What is the term statistic? Write that down. Gathering, you don't have to write down the art, you maybe write down the science. Gathering, analyzing, and interpreting data. Gathering, analyzing, and interpreting data. Data means numbers. Notice that the statistics is uppercase. Uppercase means the mathematics. Lowercase statistics has a different definition. So make sure you write down uppercase statistics, capitalized statistic, is the science of gathering, analyzing, and interpreting data. Everybody got that?
Yes.
All right. 2 branches. Write these down. And all of this that I'm covering will be, anything having to do with probability and statistics will always be on a standardized test, especially, guess what? Especially in industry and criminal justice. Why? Because what is a lot of criminal justice and industry based on? Statistics. How many bad products are being put out from this factory? Or how many people usually turn to drugs after blah, blah, blah? Or how many people steal, blah, blah, blah? You know, all that statistics. Descriptive statistics is concerned with the collection, organizing, and analysis of data. Think of descriptive statistics as your test grades. Something that you pull up, you find, you did them, you did all the work, and you averaged your test grades. That is called descriptive statistics. Inferential is when you make a prediction based on the data collected. Let's say that you are a criminal justice major and you go through a bunch of records from DOT in the past 5 years, and every year since past 10 years, that'd be what, 2000? Since 2010, you have found that every year there's 21 deaths in Anderson County by drunk driving. So, of course, we need to get rid of all cars, don't we? Anyway, if you was to take that data, which is not your data, why is it not your data? It's DOT's data, right? So you're not using your data. You're not using your test grades. And you say, as sheriff of Anderson County, you say, well, we'll probably have 20 plus, 20 around 20, DUI deaths this year. Are you using descriptive or inferential? You're using inferential because, one, you're using somebody else's data, and two, you are making a what?
Prediction.
A prediction. Is there a prediction in descriptive statistics when you get your average? No. What is it? You got what you got. You don't say, well, my test average is 82, so I'm going to predict I'm going to make an A in this class. No. You got a what? You got a B. There ain't no predicting with descriptive statistics. Okay? So we all know that if there's a number of drunk driving deaths, that everybody needs their car taken away from them, right? Because cars kill people. And we need to do that. We need to maybe get Ford, Dodge, and GM to stop making cars. Okay? Some of y'all may figure that out, in the next 30, 45 minutes. A statistician's interest lies in drawing conclusions about possible outcomes. Okay, that's a good definition, drawing conclusions. You don't have to write that down. You might want to write down drawing conclusions because nobody can tell the future. Okay? If anybody walks up to you and tells you they can tell the future, all you have to do is ask them one question. What's that question? Anybody know the question you should ask somebody? No. No, Bernie's not going to take care of any damn body. They said Bernie. Okay? But I know what you're saying. Y'all don't know what to ask a person who can tell the future? Come on.
What's going to happen in the next 5 minutes?
No. Bingo.
There you go.
What are the lottery numbers for this week's drawing? Oh, well, that's not what I do. Shut up. You're a fraud. Why? Why do I call people that say they can tell the future? Why do I call them a fraud?
Because they'd be winning all the time if they knew.
Exactly. If they could tell the future, they'd be good in Vegas. You ever seen Rain Man? Okay, you ever seen the movie Rain Man? No, of course not. It ain't having to do with Marvel Comics, so y'all ain't never seen it. But anyway, in Rain Man, the brother takes the autistic brother to Vegas because what can he do? He can remember cards. He can remember everything that's done, so he won a lot of money. That's what people that can tell the future would be doing. Would they be worried about your future and getting 25 bucks off of you or 50 bucks off of you when they can go to Las Vegas and win every single game they've played? So, how many of you have heard of 20 questions?
Yeah.
That's all they do. First of all, if you walk up to me and say, Hubert, can you tell me my future? First thing I'm going to know about you is you're depressed. Why? Because anybody that wants to know about their future has a certain state of depression in their life. Okay? Or anxiety, worrying about the what? Worrying about the future. So right then and there, I'm going to start asking you about your money situation, about your personal life, about your girlfriend or boyfriend or both or whatever. I'm going to start asking you those questions, and eventually I'm going to get down to what your problem is, and then I'm going to what? I'm going to pounce on it. I'm going to say, well, it sounds like to me that you feel like that you're, oh, how did you know that? Because I just asked 20 questions about you. Okay? That's what a fraud does. Okay? So we do not tell the future. We just make what? We make conclusion about possible what? There's a big difference between telling the future and making conclusions about possible outcomes. Population consists of all items or people of interest. Write that down. That's the definition. Your population is always your largest group. Write down largest group. If I want to find out how many people at Tri-County Tech are in the Marlboro Club, Tri-County Tech students is the population. If I use a sample, which is a smaller group, that would be, I'm just going to survey people at the Anderson campus, or I'm just going to survey people at the what? Easley campus or the Pendleton campus. And then I will make a generalization about the population. Now somebody tell me why I would want to use a sample to predict for the population. Why wouldn't I just want to do the population?
If you're sampling, you're just trying to predict it. If you're doing the population, you want to find the ultimate answer out.
Okay, you're getting there, but that ain't the reason. The reason is the two most important things in our lives: time and money.
Money.
Whether you are doing it yourself for a project and you got other things to do, or whether you are the quality assurance manager, director, executive for Bosch or Michelin, or whether you are the quality assurance or the statistics guy at the local sheriff's department, okay? The two things that are most controlling is time and money. So therefore, we have spent the last, I don't know how many years statistics has been in play, but not as long as math, because statistics is derived from math. But the last umpteen years trying to perfect predicting the population by using the sample because of time and money. Now, I'll go ahead and tell you this, and I don't know, and my whiteboard's not even on the board. I don't know where the whiteboard went. I hate when it does that. Just like it just disappears. It was up there this morning. I don't know why it disappeared. Hold on a second. It's them damn Russians. Okay, now I'm going to go ahead and I'm going to go back one. And this is where you actually see there. Formulas for population use parameters. Write that down. Formulas for population uses parameters. Remember, PP, population parameter. In algebra, what did you call a letter used in a formula? What did you call that? Started with a V. A variable. Well, in statistics, it's kind of like when statistics was invented, they wanted to make a real important math out of it, so they started using big words, okay? So instead of using variable that you used all the way up to Algebra 2 and Calculus, instead of using that, we're going to call it a parameter. And you're going to find out that a lot of things in statistics is the same thing that you learned in algebra, only it's got a fancier name. It's kind of like the guy that gets a job for doing nothing, and he has to find stuff to do because he don't have anything to do, and they just gave him a job because he's a brother-in-law of somebody that works there. It's kind of like, oh, well, we got to make this sound more difficult because we're out here by ourselves. So they call a variable that's used in a formula for the population, they call it a parameter, and it will be a Greek letter. So if you ever see a Greek letter in a presentation at work, you know it has to do with the what? Population. So if I throw up mu is equal to 35 and the sigma is equal to 2, that means that the population mean is 35 and the population standard deviation is 2. So from here on out, if you see in a presentation, no matter if it's at work or school, and they throw up a Greek letter, then you know it has to do with the population. Formulas in sample calculations uses not a parameter, but lowercase statistic. Make a note of this because you're going to get it confused, and that is a standardized test question. lowercase statistic in its formulas. And they are usually regular letters. So if I throw up an X bar is equal to 28 and S is equal to 3, then you know that that has to deal with not the population, but the what? Sample. So, population, parameter. Sample, lowercase statistic. And statistic and parameter is basically formulas of variables used in the population formulas, variables used in the sample formula. That's very important that you understand that. Everybody got that down?
Yes, sir.
Okay.
Yes, sir.
There's lies, damn lies, and statistics. Anybody know who said that?
No, sir.
Nope.
Nobody's going to guess because y'all don't talk.
Who said it?
Hubert did it.
No, I didn't say it.
Who said it?
I'm not that renowned. I've said that don't have a champagne taste on a beer budget, but I don't think I invented that either. I was going to pull it up for y'all, so y'all don't think I made it up. There's lies, damn lies, and statistics. Who said it?
Hey, you did say it.
Mark Twain. Write that down. Very famous quote. Is it true? 100% yes. 100% yes. Now I want somebody to read that and tell me what that means. That means that if you wanted to, you could make statistics say that water runs uphill. Okay? That's why a lot of people, when you say, let me just give you an example. Let's say that I walk up to you at a party and I say, hey there, how are you? And we introduce ourselves, and you're an engineer, and I say I'm a statistician. Sometimes people will laugh at a statistician and say, oh, so you couldn't make it as a mathematician. Does everybody understand what I just said? Mm-hmm. Sometimes statisticians are taken like the chiropractor of medicine. Okay, you know how chiropractors are treated in medicine? Kind of like the stepchild. Well, sometimes statisticians are treated like that because of what others have done with statistics. What has others done? Good or bad? Most of the time bad. If you've got a world-renowned author that says there are lies, damn lies, and statistics, that means some people have been doing some bad things with statistics. Okay? There's one thing you have to have with statistics, and that is called neutrality. What is neutrality? That means I want y'all to answer. That's what I want y'all to do.
Is it like getting your information from like a neutral site?
Yeah, neutrality is the opposite of biased. And I hope I spelled neutrality right. A neutrality is like a judge, or unless you're, okay, I'm excluding Clemson fanatics because they don't believe this, okay, because anything goes wrong with a Clemson game, who do they blame? The referee, okay? So, referee or a judge is the most neutral jobs that I can think of. Okay? Now, I'm not saying I'm a judge in no means, but I sit on a board called the Land Use Board. I'm going to give y'all an example of what I'm talking about. And this was about 6 months ago. And a guy came up to the Land Use Board and said he disagreed with Anderson County on this rule, blah, blah, blah. He had a lot that was below the square footage to put a septic tank in. Does everybody understand that? In other words, you can't put a septic tank on a parking space, okay? You got to put a septic tank in at least 3/4 of an acre. Does everybody understand that? He didn't have 3/4 of an acre. He had like 1/10 under 3/4 of an acre. All right? So I sit on the board with 6 other people from each district, and we listened to the case. We listened to him, and then the people in the community came up and they all bashed him and said that he was terrible and all this stuff, and that he was going to put a mobile home on it, going to put a bar on it, going to put a strip club on it, going to put just all these crazy things. And I'm the chairman, so I said, whoa, wait a minute. I said, is there any reason besides what you think he's going to put on this property that he should not have a septic tank on this property? Well, no. Okay? And then I closed the public hearing and I said, okay, before we vote on this, I would like to say the following. This Land Use Board doesn't care one bit about what? About what he puts on that property. Okay? Is that for anybody to decide whether you can put a shop on your property or whether you can put a house on your property? That ain't got anything to do with what all we were doing. We were judging whether he should get a waiver on the square footage of the lot. Does everybody understand that? So I told the people, I said, we cannot get into what he's going to do with the property because that's none of our damn business. Okay, now what was I being? I was being neutral. Okay, because I didn't grow up in one. My first 10 years of my marriage, I lived in a mobile home. So anytime somebody talks about a mobile home in a negative way, I kind of cringe a little bit. Okay? And second of all, I cringe when somebody tries to dictate to me what I'm going to do with my property. So, but I could have voted against it and said, well, I don't like mobile homes, so I'm going to vote against it. I didn't. I told the crowd that was there was about 25 people there. There was about 10 talking for it, 10 talking against it. I said, our job as a board is not to get into what he's going to put on the property. That's none of our business. Our job as a board is to see if there's a hardship to where we can grant a variance for 2/10 of an acre. Does everybody understand that? Mm-hmm. So as a board, we have to be what? Neutral. We can't say, oh, well, we don't like mobile homes either, so we're going to vote against it. So with that being said, we voted against it because we didn't want to set a precedent because everybody with 2/10 acre lot below would be put in for a variance. And he had no medical hardships. There was no kind of physical hardships. There was no financial hardships. There was nothing there to say there's I'm putting my grandma up. She's 92 years old, and that's the only place I have to put her. And that would have been different. Okay? But neutrality is very important. This is what Mark Twain was talking about. There's a lot of times I can prove something to you if I give you a false assumption. Okay? A lot of times in statistics, they start off with a false assumption. And you have to be very careful of this. Whether you're presenting, whether you're doing research, or whether you're watching a presentation. You have to be very careful. Okay? You draw a conclusion But you have to make sure that all through everything that you're very what? Neutral. Now, I guess that was my alarm to shut the hell up. Let me see. Y'all get out at what, 1:15?
Mm-hmm. Yes, sir.
Y'all not lying to me, are you?
No, sir. He said we're not lying to him, and I said no, sir, we're not.
Heck, why is my battery's dead? Okay. Oh well. Let me talk for a couple more minutes and then we'll go. Random sample. You ain't got to write any of this. All you got to write down is the last sentence. Write down that last sentence, and I'm going to draw on it. Don't forget it. I'll just say it. Each item has an equal chance of being picked. Each item has an equal chance of being picked. Now, you're going to be asked that on some test, whether it's my test or whether it's a standardized test. That is a test question. Each item has an equal chance of being drawn. For instance, if I was to take each one of y'all, give y'all a yellow Post-it note, tell you to write your first name and last name on it with a red pen. Each one of you, I give you a red pen, and I tell you to fold it in half and put it in a punch bowl. Is that a random sample? Yes. What if one of you throw away the yellow Post-it note and use a pink Post-it note? Is it a random sample then?
No.
No. Because if I'm looking at the punch bowl and I'm going to either go away from that pink one or I'm going to pick that pink one. So the neutrality has been compromised. What if I use a yellow Post-it note and instead of folding it in half, I fold it 16 times? Is that a random sample? No, because even if I was blindfolded and I was reaching in the punch bowl to pick the problem or pick the name, if I feel that wad of paper, I'm either going to get away from it or I'm going to what? Pick it.
Pick it.
And therefore, the neutrality is swayed or compromised because somebody did something what? Different.
Wrong.
A random sample, a good word for random sample is everything in the sample is uniform. Write that down. Uniform. Uniformity has a lot to do with a random sample. Okay, let me see what the next one is. I want to get to a good stop. That's what Okay, let's just stop at random sample because there's five different kinds of samples, and I'm going to stop at random. So I need y'all to write down random sample, and that's where we're going to pick up, okay? All right, let me shut off the recorder.